Okay.
There's the diagram.
So we have one more little section here about solving equations, and then we're going to do something a little bit different with imaginary numbers. But right now, we are going to solve these equations with radicals in them. So, does anyone have an idea how we might solve this problem right here? Square both sides. Perfectly legitimate move. You have to square both sides. Obviously, you can't do just one side. You have to do both sides. And we talked about this the other day. If you square a square root, they cancel, and all we're going to have left is x plus 2, right?
Yep.
Equal to, same thing on this side, 3x minus 1. So now you have just a plain, simple, basic little equation that I know you know how to solve. So we'll subtract x. Oops. So it looks like we get x equal to 3/2. Did I do okay?
It's okay, but 1.5.
1.5 is the same thing. James Wayne, you good with that?
Wait, instead of adding, instead of subtracting oh, wait, never mind, I know what it is. Never mind.
Yeah, you're going to get the same answer.
I ended up adding the x from that I subtracted. Yeah, I see what
All right,
you
so
mean.
you got it?
Yeah.
Okay. Now, can we do the same thing with this problem?
No.
No.
Well,
Yeah,
we
yes.
can, but we have to be
Gotta
careful.
square the 2 outside of it, don't you?
If you, personally, I like to go ahead and divide by 2 first. So I have this. Divide both sides by 2, so my radical is by itself. Your teacher last year may have called that isolating the radical. That's what we say sometimes. We're going to isolate the radical, get the radical by itself. Now I'm going to square both sides. Now this side just becomes x plus 1, right? Because we're squaring the radical.
Yep.
But this side you have to square. When you square a fraction, you square the top and you square the bottom. So that's going to be 9/4.
Yep.
And then we'll subtract 1. And this is another place where kids, you're big kids, we just have to deal with this. 9/4 minus 4/4
5/4.
would be 5/4. Everybody okay? Look at the next one. Ay, 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 ay. This is a big problem.
This fourth.
Yeah.
Can you explain how you got the 4/4?
1, I'm getting a common denominator.
Oh,
So that was a 1, and a 1 would be 4/4, so that I can subtract it from the 9/4.
yeah.
It was a 1. Now, is the radical already by itself in this problem?
Yeah.
Yeah. So I'm going to square both sides.
When you get x squared.
But gang, when you square both sides, you are literally squaring the side. You're not squaring the individual pieces. You're squaring the whole side. So this is just going to be 5 minus x. But this is a FOIL. You cannot square individual pieces. You're squaring both sides. That's how you described it to me. You said we're going to square both sides. So you're squaring the sides. So 5 minus x equals x squared plus x plus x plus 1. Please tell me you remember foiling, F-O-I-L, first outside, inside, last. So x times x times 1 times x, 1 times 1. What in the world?
X squared plus 2x plus 1.
Alright, so I can, over there.
Get 0 once.
Get 0. This is what kind of an equation? Quadratic. You always want your quadratic set equal to 0. Whether we're graphing them, whether we're using the quadratic formula, whether we're factoring them, it doesn't matter. You want to get them set equal to 0. So you're going to subtract 5 and add x, right? So we got our 0. X squared plus 3x minus 4?
Yep.
Now, what do you want to do with that? Let's just pause for a moment. Somebody said factor. That is one of your options. What are your other options? Complete the square or quadratic formula. No one cares. Just get it done. Okay? Just get it done. So if you don't mind factoring, some of you like to factor, and that's awesome. This one does factor. How does it factor?
X plus 4, x minus 1.
Plus 4 minus 1. So your answers are negative 4 and positive 1.
Yep.
Now I didn't talk about it with the first two problems I did because they were so easy. There wasn't really much involved with those. This was a little more complicated, would you agree? And when they get like this, we have to check for what are called extraneous roots. Have you heard that word before?
Yeah.
What does it mean to be an extraneous root? Means it doesn't check. Now, we made no mistakes. We did a perfect job on this problem. But whenever you square both sides, you run the risk of ending up with too many answers. So what we're going to do is we're going to check these guys, and we're going to check them back in the original problem. So I'm going to rewrite my original problem. There it is. And I'm going to check my answers. So I'm going to start with the negative 4. So I'm going to put negative 4 in here. So I have 5 minus negative 4 and negative 4 plus 1. What's 5 minus negative 4? 9. The square root of 9 is 3. What's negative 4 plus 1?
Negative 3.
Uh-oh, we've got problems here. Those don't equal. This is an extraneous root. It's simply an answer that doesn't check. You didn't make any mistakes. It's not like you screwed up. You didn't.
It's still the right answer.
No, it's crossed out. It is not an answer because it doesn't work in the problem. Doesn't make it true. Let's try 1. So I'm going to put in 1. So 5 minus 1, 1 plus 1. I put in 1 for the x's. I'm checking this answer. What's 5 minus 1? Square root of 4 is 2. What's 1 plus 1? Oh, that one worked out okay?
Yep.
So the only answer to this problem is right here. Now, if you put both of them down, you're going to get most of the credit, but if you want full credit, you got to notice that one of those roots is extraneous.
Is that all problems?
What?
Is that all problems like this?
No. Actually, I wish it were that easy. Sometimes they both work. Sometimes neither one works. Sometimes both of the roots are extraneous. You just never know till you check them.
Oh.
Just one of those fun things about math. You never know till you check them. Okay, one more of these. Any idea how you might start?
Isolate.
So maybe we'll start by
-5.
-5. Divide by 2. And then square. So this one doesn't have any foiling or anything, it's just squared. So over here I'll have x minus 3. And over here I'll have 1. So x equals 4. Now I want you to check that. Go back to the original problem. Here's the original. Put a 4 right here. Let x be 4. 4 minus 3, 1. Square root of 1 is 1. Times 2 is 2. Plus 5 is not 3. So guess what? This problem has no zeros. Emma.
Wait, so like we subtract over, but then what happened to the 2 outside the radical?
We divided both sides by 2, and that's how that got to be a 1.
Oh, okay. Never
Is
mind.
the answer just no solution?
No solution. It is so easy to get on a roll and forget to check your answers. Try to remember when you square both sides, when you do this step right here, that's when you have to be on the lookout for extraneous roots. Okay? All right. Now, what time is this period over? 8:50? All right, let's do a couple of these eye problems and then I gotta stop because we need to do a quick review and I got a couple papers to hand out to you. But let's do a couple of these because they're so easy. What's eye? What are we talking about when we put these eyes in here? I is the square root of -1. So when we see that I, it's what we call the imaginary unit. It signals that now we have imaginary numbers. Yeah, hate to keep you up. All right, now I want to add, these are two imaginary numbers and I want to add them together. Do not make this hard. You're going to add like terms, right? That's it, it's that easy. There's nothing tricky or different. So we've got a 3 and a 2, so that'll be a 5. And an I and a -4i, so -3i. Done. Done. Now the next one is just as easy, except you have to pay attention to that. Just like you do with regular polynomials, when you have a negative outside of a parentheses, you have to remember to distribute it all the way through. So we got a 4 plus 3i minus 6 minus I.
Yep.
And then we collect like terms. So we have a 4 and a -6.
2i minus 2.
And a 3i minus I. So -2 plus 2i.
Yep.
All right. We'll do one more. We'll do the multiply and then we'll stop with that for the day. So let's do the multiply. How do you think we're going to multiply these two numbers? We're going to FOIL them. We're going to FOIL them. I know these are I's, but it's no different than having X's in there. You're going to FOIL it. So first times first,
Well,
outsides,
-9i.
3 times -3i, insides, and less. Now, obviously, obviously these two add together, right? So I have 12 minus 1i minus 6i squared. Now that needs some attention. Does anybody remember how we handle I squared, Miss Ruffle? It does equal -1. Kids, if I is the square root of -1, what happens when I square both sides? Doesn't that cancel out?
Oh, that's cool.
So I squared is -1. So every time you see an I squared, you are going to replace it with a -1. I squared is -1. So this becomes plus 6, which can be added to the 12, and your final answer then is 18 minus I. Right?
Yep.
Okay. All right, let me, I want to do a quick review here with you because we're going to have a quiz next time I see you. And I want to make sure you know what you have to do on the quiz.
Stop for nobody.
Nope, never ever. All right? So the directions are going to say, these are your practice problems. I'm telling you, like I always do, exactly what's on tomorrow's quiz. Okay? A question like this that says, solve using the quadratic formula. Now, we're grown up. I'm not giving you the quadratic formula. You are not going to cheat. You're not going to write it on the palm of your hand. You are going to do the right thing and you're going to memorize it. Hopefully you've already done that. I would definitely write it on my paper though. X equals -b plus or minus square root of b squared minus 4ac all over 2a. That's the quadratic formula. So in my problem, what's A? 1. What's B? -4. What's C? C? -3. So here we go. X equals 4 plus or minus the square root of 16 minus 4 times 1 times -3.
Plus 12.
So that is, somebody said that's 4 plus or minus the square root of 16 plus 12.
12, yeah.
Everybody get the positive 12 there? Now when we're doing this together and I'm up here yakking away, nobody makes mistakes. Be careful on your own. So that's going to be 4 plus or minus the square root of 28.
Which is 2 root 7.
The square root of 28 breaks down. It's 2 times 2 times 7. So 4 plus or minus 2 root 7 over 2.
Then you divide.
And since all 3 positions are divisible by 2, we cancel a 2 out. Kids, if you tried to cancel at this point, I know 2 goes into 4. But you have a 3-part problem. If you don't cancel out of all 3 parts, you can't do it. So don't cancel here. You've got to cancel here. So the final answer is 2 plus or minus the square root of 7. Because that 2 goes into here and into here. So that's the final answer to the problem. Okay? Now, The second question on the quiz, or another question on the quiz, I don't know what order it'll be, but a second question says, x squared minus 4x minus 3 equals 0. Complete the square. You're saying, Ms. Ford, it's the same problem. Yes, it is. But you're going to do it an entirely different way. And what better happened?
You get the same answer.
You better get that answer again, right?
Yep.
If you don't, then somewhere you've messed up because it's the same problem. So, completing the square. Anybody remember step 1?
Take the other.
Take the 3 to the other side. Leave the gap, because you know what you're going to do now. You're going to figure out a number that you're going to add to both sides. That's how we complete the square. That's the process. Who remembers how we find the number that goes on both sides? Evan?
Divide by 2 there. Yeah, divide the 4 by 2 and then square.
Yep.
Yeah.
So 4 divided by 2
Big
is
negative
2.
Squared.
Squared is 4.
Four.
Now remember, the negative is going to get squared out. So I'm not even going to confuse myself with the negative. Because I'm going to square and it's going to be positive anyway. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. The whole purpose of doing it is so that I have a square. It's called completing the square. This needs to be a square. What square is this? X minus,
Four.
that sign right there, minus
4.
2. You gotta square it and get 4,
Oh.
right?
Yep.
If you put a 4 here, you're going to get a 16. You don't want a 16, you got to have a 4. So x minus 2 squared equals 7. Now what? Square root both sides. So x minus 2 equals plus or minus root 7.
Yep.
Remember, when you square root a plain number, it's always plus or minus. So if we add the 2 to the other side, we have 2 plus or minus root 7. Does that look familiar?
Yes.
That is exactly what we got up there, right?
Oh, yeah.
Okay.
So your quiz tomorrow is going to look like that, and then you're going to have one more problem. And you know what that's going to be, because some of you don't know your distance formula, you don't know your midpoint formula, and you don't know how to find slope. All right, so here we go. Some of the quizzes are going to say find midpoint. Midpoint is average, and I'm going to write that word right down here so I don't forget. It's average. So 1 plus negative 3 divided by 2, and 4 plus 5 divided by 2. There's my midpoint. Add them and divide by 2. Add them and divide by 2. What's this? Is that negative 1?
Yep.
And 9/2? So somebody's quiz is going to have that question. Somebody's quiz is going to have this question. Slope y minus y over x minus x, y minus y over x minus x, so negative 1/4. And somebody's quiz is going to have this question, which is the distance.
Yeah.
So 1 minus negative 3 squared, x minus x squared, y minus y squared. So what is that? 1 minus negative 3
Under 4.
Squared.
16.
4 minus 5.
Negative 1.
Squared.
1.
The square root of 17. I got one thing to give you. Don't forget to sign up for that before you get down. Haven't done that yet? Here's some extra problems. Like, you might want to do. This is P5, yep. In your homework, it says there's extra problems. It's P5, here they are. Please make sure that your legs and markers get put back away. Nobody leaves the room till I get my calculators back. Doesn't matter, you can't leave the room till I get them back. I need 7 of them back. I only have 2 so far. Who else got them? Here comes 3. You didn't mind putting the covers on, so you didn't turn them off, and now nobody leaves, so I get them back. 2 more. 2 more. Can't leave, so I get them back. Who's got them? Who's got my calculator? Here's 1. 1 more.
No, that's fine.
Who's got my calculator?
Just take one for the team, man. Put your name
All
on
right, you're out of here. See you tomorrow. Have a great day.
Actually, I'm still with that.
Come on, Adam, let's go to government.
Magnus, will you hit me off?